engine generates power from the expansion of compressed air in a contained cylinder with the help of fuel. That is why it's called as an internal combustion engine. Before getting into the working, let's see the main parts involved in the working of an engine. First, the crankshaft. This is the part which converts the linear motion of the piston to a rotational force. Next, the pistons and the piston rods. The pistons will be pushed down by the expansion of compressed air, and turns the crankshaft. And the valves, which controls the flow of air and fuel into the cylinders. These valves are driven by the intake camshaft, and the exhaust camshaft, and the camshafts are driven by the crank itself, using a timing belt. There will be idler pulleys, and a tensioner pulley, to hold the belt tight in place. This here, is the internal structure of a 4-stroke, inline 4-cylinder, DOHC engine, which is commonly found in most hatchback and sedan cars. A 4-stroke engine should pass through 4 different strokes, to complete one cycle to produce power. They are intake, compression, power, and exhaust stroke. The crank to camshaft ratio is 2:1, which means it will take 2 crank revolutions to complete 1 camshaft revolution. And the camshafts are designed in a responsive manner, to open or close based on the corresponding strokes of each cylinder. Let's take a look at a single cylinder, and see how a 4-stroke engine works in detail. In order to ignite the air-fuel mixture, a spark plug is used. This will ignite the compressed air-fuel mixture, with the help of an electrical spark. We will take it down by each stroke. The intake stroke. The inlet valve opens and the downward movement of the piston creates a suction. This pulls the air-fuel mixture into the cylinder. Once the air-fuel mixture is in the cylinder, compression stroke begins compressing the mixture. At this time both inlet and outlet valves stays closed. At the end of compression stroke, the air-fuel mixture is ignited by the spark plug. The explosion exerts pressure and pushes the piston down. This is the power stroke which produces power to the crank. At the exhaust stroke, the outlet valves opens and the piston pushes out the burned gas. The cycle starts again from intake stroke, keeping the engine running and produces power. For a carburetor engine, the air and fuel are mixed inside the carburetor assembly, and fed to the cylinders. In the case of a fuel-injected engine, the fuel is injected into the intake manifold, or directly into the cylinders. Since only a power stroke produces power, you may wonder how the engine turns continuously. Well, the answer is in the crank itself. The flywheel and the crank counterweights provides momentum, which keeps the crankshaft from stopping immediately. For a 4-cylinder engine, considering any time instance, one cylinder is always in power stroke, which produces more power and less vibrations comparing to a single-cylinder engine. And that is how a car engine produces power in simple. A car engine is basically an internal combustion engine where power is generated through expansion of high temperature and high pressure gases. A lot of heat is generated due to the combustion gas and the friction of mechanical parts. For sustained operation, these excess heat should be removed from the engine and kept at operating temperature. Now let's see the parts involved in cooling the engine. The main parts for cooling the engine are water pump, radiator, thermostat, coolant temperature sensor, and coolant. First, the water pump. Water pump is the heart of the cooling system, which pumps the coolant. It consists of an impeller, a pulley flange, and an O-ring. The impeller is driven by the engine drive belt, through a pulley. Next, the radiator. The radiator is a heat exchanger, used to transfer the excess heat, developed by engine to the atmosphere. The radiator is having an inlet port, outlet port, a drain plug, and a radiator pressure cap. The radiator pressure cap plays a vital role in the cooling system, which will be explained later. Next, the thermostat. The thermostat is a valve which regulates the flow of the coolant, and helps to maintain the proper operating temperature for the engine. The thermostat consists of a frame, charge cylinder, main valve, main spring, bypass valve, and secondary spring. Next, the coolant temperature sensor. The coolant temperature sensor is used to monitor the engine temperature. The ECU will use this data to manage fuel injection and ignition time. Some engines have more than one coolant temperature sensor. The data is also used to control the radiator fan and to update the temperature gauge on the driver console. The coolant temperature sensor consists of a sensing probe and an electrical connector. Most coolant temperature sensors are negative temperature coefficient type, which means as the temperature increases, the resistance will decrease. The CTS can be a 2-pin type, or a 3-pin type, depending on the make of the vehicle. These are the main parts involved in an engine cooling system. Now, let's see how these parts works together. The pistons are contained inside the engine block, in which each of them will function. Above the engine block comes the head gasket, which provides sealing between engine block and engine head. It avoids compression leaks, and oil or coolant leaks into the cylinders. Above that comes the engine head. The engine is having a safe passage, through which the coolant can flow without entering into the cylinder, or mixing up with the oil. This passage is known as water jacket. Let's put the parts one by one, and see how it works. The water pump pumps the coolant throughout the system with the help of the radial impeller. It is driven by the engine itself, using a serpentine belt. The serpentine belt also drives the power steering pump, alternator, AC compressor. But for now only water pump is shown. Now let's see the connections. The thermostat bypass hose. The thermostat housing. Inside the thermostat, the radiator, and the radiator fan. The lower radiator hose. The water pump outlet hose. The upper radiator hose. The coolant expansion tank. The expansion bleed hose. Coolant overflow hose. So, finally, let's get into the working, starting with the thermostat. The thermostat is actually a valve, which regulates the flow of the coolant. It will always be covered in the coolant, so that the temperature can be sensed. Let's start the operation from a cold engine. When the engine is cold, the bypass valve stays open. So, the coolant bypasses the radiator and recirculates through the engine. This helps the engine to heat up to operating temperature quickly. Eventually, the coolant temperature increases by absorbing the heat from the engine. Once the coolant starts to reach higher temperature, which is usually between 160 to 190 Fahrenheit, the bypass valve will start to close, and the main valve will start to open. This allows the cold coolant from radiator flow to the engine side, and the hot coolant from engine side flow to the radiator. In most cars, the coolant temperature sensor is located near the thermostat housing. It will turn on the radiator fan if the coolant to the radiator side is at high temperature. Now, The hot coolant in the radiator will release its heat to the atmosphere with the help of the fan. At the same time, the cold coolant received from the radiator will start to absorb the heat from the engine for the next cycle. Heating liquid inside a closed system always builds up pressure. So, how to maintain the pressure? Here comes the role of the radiator pressure cap. It consists of a spring-loaded valve mechanism, which will respond to higher pressure. Reaching a pressure above 15 psi will push the pressure cap valve, and the coolant flows to the expansion tank, until the pressure goes down to operation level. And when the system cools down, the vacuum inside the system sucks back the coolant from expansion tank. In case if there is too much pressure build-up in the system, due to trapped air, or other failures, the coolant in the expansion tank will be pushed out through the overflow hose. The car heater system is a part of the engine cooling system. The heater system comprises of the heater core, inlet and outlet hoses, a heater control valve which is optional and cannot be found in all vehicles. The heater core acts as a radiator, dissipating heat from the hot coolant to the vehicle interior, using a turbocharger. Is nothing but a centrifugal compressor. The principle here is forced induction. It's the process of forcing compressed air into the intake for combustion. First, we will see the basic parts of a turbocharger. A turbocharger consists of a compressor housing, compressor wheel, turbine housing, connecting shaft, bearings, and oil seals. The middle part held together is called a cartridge. The compressor wheel and the turbine wheel are connected with a shaft, so that turning the turbine wheel will turn the compressor wheel. A turbocharger is designed to rotate over 100,000 RPM. An oil feed line from the engine will lubricate the shaft and the bearings, providing less friction. Now, let's see how the turbocharger works with the engine. An engine without any forced induction device is a naturally aspirated engine. The air is pulled in through an air filter by the suction force of the piston. Then it gets mixed with the fuel, compressed, and gets ignited. With the turbocharger introduced, the exhaust gas from combustion turns the turbine wheel. This turns the compressor wheel, and more air is compressed and fed to the engine. Let's take a closer look. The exhaust gas from the engine will push the turbine wheel, and this turns the compressor wheel, forcing more air into the engine. According to gas laws, for a constant volume, increasing the air pressure will increase its temperature. So there will be a difference in temperature after charging. Forcing this air into the engine can reduce efficiency and cause knocking. In order to cool this air, an intercooler is introduced. An intercooler is an air-to-air heat exchanger device, which helps to cool this air before it enters the engine. So introducing an intercooler into the system will increase the charge density by cooling the air, and provides volumetric efficiency. In conclusion, a turbocharger will provide more air to expand on combustion, and produces more power.